So in that particular point, when you calculate this, you have to first of all find out this value. Okay, we need not to make it quite difficult or complex. If you want to know why or whether these two equations came from, it's pretty much easy. As you know, e to the power z theta is equal to cos theta plus sin theta divided by 2. Cos theta plus j sin theta, sorry, j sin theta divided by 2. That's the thing. Okay, the Euler's formula, the Euler's theorem, you can find it out, the Euler's theorem, that how an exponential term could be transformed into a trigonometrical term. There is a trigonometrical term, there is an exponential term. So that is the transformation. But you need not to do this, that will be too much critical. So first of all, think about it. Just k is equal to 0, 1, 2, 3. Put the value here, x 0. Make the value 0 here. Just put the value k 0 here. Let's find out by calculating with your calculator, or else you will find the value is 6. You will find that the value is 1 minus j. Find the value 0. Find the value k for this is minus 1 plus j. How that is been calculated? Just listen. 1 plus e to the power j into 0 means totally 0. E to the power 0 is equal to 1. E to the power 0 equal to 1. E to the power 0 equal to 1. 2 plus 2, 4, and other 2 are equal to 6. As you get it. Okay. Let us go to the next part. What is k equal to 1 can do? Just make k equal to 1 here, k equal to 1 here, k equal to 1 here. So there is 3 pi by 2 j theta. That is the pi. That is the pi by 2. Just calculate with it with the trigonometrical form. E to the power minus j theta is equal to cos theta minus j sin theta divided by twice j. So just put the value of the theta. That is theta means pi by 2. The angle. You know cos 90 means 0. Sin 90 means 1. Again, if you find out pi, that is cos 180 degree is minus 1, sin 180 degree is 0. So calculate the total thing, you will find out minus 1 minus j. After that, put that value 2 here. If you put value 2 here, that will be e to the power minus j pi. That will be e to the power pi by 2, and that is the j pi. So after calculating it, the cross will come along and it will make it to 0. That's the thing. And if you put the value k equal to 3, that is totally based on your calculation, how you will calculate it. That's not so difficult, but it is a mere calculation of higher mathematics that you have to know. That's not a big deal. You have to keep remembering one thing, that is gonna be the equation xk. The equation xk, that's the only thing. Otherwise, each and every sequence, whatever else it might be, you could easily calculate it and calculate the DFT. So computation of the DFT is not too tough. Rather than you have to understand the basic mathematics, the higher mathematical terms, trigonometrical terms, and Euler theorems. None of the else will get you to the fact. Everything will be on your cards and you will easily calculate it. Now, so what is the symmetry? The symmetry means the magnitude and phase functions are even and odd respectively. Okay, so the magnitude can be even and odd, and the DFT also has circular symmetry. Okay, what is the symmetrical thing? What is the even and odd? Just go to this slide. Just check the slide. There are two complex conjugate numbers here, right? There are two complex conjugate numbers and there are two real numbers. So they have the symmetry. That is the symmetry. Symmetrical points are there. 2 poles and zeros lies on the imaginary and real parts, real value. The DFT also has circular symmetry. In later part of the video, in later part of the lecture, we will know how the circular DFT could be calculated. So that is a circular DFT. As you can say, it is circular DFT. So that is circular value. They have used just n minus k to make it circular. That means periodic. Just make a period with a minus k. Just they put it on, get this thing. But that is the only thing. That is the only thing that is still remains. And for n equal to 0, 1, 2, 3, whatever else you give, it will produce just 1. So that is the periodicity. That is a circular thing that get backs on it. And also the complex conjugate of xk, complex conjugate, that is also a part of circular thing. When n is even, the symmetric about n by 2. When the phase xk has odd symmetry about n by 2. So when you will get odd symmetry, you will get the phase. When you will get the even symmetry, you will get the modulus, that means the absolute value. That's the thing. Okay, now going back to the next part. So that is the inverse DFT. Okay, inverse DFT. So what is inverse DFT? Inverse DFT is just inverse of the inverse of the discrete Fourier transformation. The Fourier transform, as you can see in the earlier videos, how you can find out the Fourier transform. So in the next part we will know in the inverse DFT in the next lecture. That will be a new lecture, so stay tuned.